Hey guys, my name's Callan. I'm a graduate software engineer, and recently I've been doing a lot of research on understanding and implementing OAuth 2. I think OAuth 2 can be a super difficult subject to research, as I found there's a lot of misleading information on the internet, so hopefully I'll be able to clear up any confusion surrounding it with this video. This video will discuss what is OAuth 2, what problems does it solve, we'll take a look at the OAuth 2 flow and how that works, and finally we'll summarize with the benefits of using OAuth 2. So, what is OAuth 2? From a user perspective, OAuth 2 is these buttons that can be used to sign in to websites. From a developer's perspective, OAuth 2 lets you request access to a user's data from another app or service without needing their password. So essentially, OAuth 2 is a protocol that was invented with the purpose of giving developers and apps an easy and secure way to access user information from a third party through the means of authorization and authentication. So using OAuth 2 in your applications, you can easily get access to user information such as emails, names, and images, for example, and you can also gain permissions to read and write to calendars, emails, or contacts, for example. Both of these actions can be done by asking the user to sign in with a third-party OAuth provider, saving you time and effort in development. This is done using OAuth 2's core principles, authentication and authorization. Let's discuss what each of these are. Authentication is verifying that a user is who they say they are, and if this is done successfully, user information is returned on successful login. Authorization is granting your application permissions to alter a user's resources. Before I go any further, I should mention that authentication wasn't initially something that you could do with OAuth. OpenID Connect was a protocol that was added to OAuth in order to allow it to be used for authentication. However, these days, they are one and the same, so we will treat them as such going forward. Before we look into understanding how OAuth works, let's take a look at some older methods of authorization and authentication to get a good understanding of the problems that OAuth solves. First, let's look at how authentication was and still is done with simple login forms. Simple login forms work by having a user create an account for your application. You then store their information and compare it to their subsequent login requests in order to determine whether they are who they say they are or not. Simple login forms are often used alongside OAuth in case a user doesn't own an account with any of the providers, and it works, but this doesn't mean that it comes with its flaws. One issue when using a simple login form is that you as a developer are responsible for the creation of the form on the front end as well as any encryption logic for passwords. This means you have to be aware of any security issues you could be susceptible to as a result of your form, such as SQL injection attacks or the likes. Another issue you could face if you choose to deal with authentication in this way is that you're responsible for the storing of sensitive information, and again, this could become an issue if you're targeted by any cyber attacks. Now, taking a look at authorization, as you can see in this image, this is how third-party authorization was done back in the day. Basically, Facebook wanted to tell all your friends via email to come and join Facebook. The way they done this was by asking for your email provider, your email, and your email password so that they could log into your account and email all your friends. This obviously is far from best practice, and you should never give anyone your passwords like this. So on one hand, this did work to allow Facebook to access your email account, even if it was doing so in a completely unrestricted way, meaning you couldn't choose what they could access when they get into your account. But it did this in a way that meant you had to share your password, so this was never a sustainable method of authorization. So, how does OAuth 2 solve these issues? Well, Farmville, for a lot of people, might have been their first encounter with the OAuth 2 protocol, and is a much better example of how to gain access to a user's resources from a third party. In this example, instead of Farmville asking you for your Facebook password so that it can post to your wallet at Farmville, it redirects the user to an authorization server hosted by Facebook in order for them to grant Farmville access to the set of scopes that you can see they are requesting on the left of the image. This method of gaining access to a user's data is clearly much more secure. There's no Farmville managed login form here, avoiding all the security risks that come with that method. Instead, they get your basic information from Facebook. Most importantly though, there is no password sharing going on here in order to gain access to user resources, making OAuth 2 revolutionary in terms of securely sharing data. So, before we can dive into how OAuth works, there are a few concepts we need to understand. First up, we have the resource owner. The resource owner is just a fancy way of saying the user, the person who owns the resources that we want to access. Next, we have the client. This is the application that is requesting access to the resources. In the previous example, the client would be Farmville. Then we have the scope. The scopes are values that are provided when asking the user for permission and are basically a list of things we would like access to. In the form of the example, this would be something like permission to post to a person's Facebook page. Along with the scope, we also send a redirect URI in our request when we ask for permissions. This URI will basically be a link to a callback page in your application that the user gets redirected to after granting you access to their stuff. Then we have the authorization server. This is what the client asks for permission to access the data, and where the resource owner gets redirected to in order to grant access to the client. The image on the last slide was of the authorization server. The authorization server then returns an authorization code. This is a code that will be presented in the query parameters of your redirect URI that can later be exchanged for an access token. The access token is essentially a token that allows you to access user resources. This is what you will present when making requests to obtain a user's basic information or alter their calendars, for example. Finally, we have the resource server. The resource server is where you access user resources, and as I just mentioned, you need an access token in order to make a valid request to the resource server. Now, let's take a look at how OAuth works under the hood. So, first of all, we have the resource owner, the client, and the OAuth provider. This is where the first step in the OAuth flow takes place. The resource owner will click the Sign In with Google button, and the flow will commence. When the button is clicked, the user will be redirected to Google's authorization server, where they'll be prompted to sign in and decide whether they would like to give the client access to their data. As you can see here, within the link that the user is redirected towards to grant access, there are query parameters that include our redirect URI, our response type, and our scopes. Once the resource owner has granted permission, they are redirected back to the redirect URI. However, now within the query parameters of the URI, we can see there is a code. This is the authorization code that is needed in order to obtain an access token. To do this, we then go back to the Google authorization server with the authorization code, only this time the user is not redirected. This is done via a standard post request, and we exchange our code for an access token. Finally, now that we have the access token, we can use this to get access to user resources and information from the resource server until it expires. The main question I had when researching this flow at first was, why do we get two different codes? And why do we get a code, then exchange it for a token? The answer to that is because you don't obtain the authorization code in a secure manner, but you do with the access token. In this diagram, the solid lines represent a front-end channel and the dotted lines represent a back-end channel. As you can see, the authorization code is transferred using the front-end channel, and then access token is transferred over a back-end channel. This means that there is a chance the authorization code could be intercepted. However, it would be useless by itself, as you still need information such as the client ID and the client secret for your project, along with the authorization code to obtain an access token. This is then done on the back end and is not exposed to the browser, making it more secure. So, what if I want to implement OAuth 2 in a purely front-end application with no back-end available? Well, there are two main flows to consider when working with OAuth 2. There's the authorization code flow, which is what we have just covered. This incorporates front-end and back-end channels for secure acquisition of an access token. And there's also the implicit flow. This is a front-end only flow and would be how you acquire an access token with no back-end available. As we can see in this diagram, the flow is very similar to the authorization code flow, except all the communication is done over front-end channels. The only differences in the implicit flow compared to what we've seen before is that we request a response type of token instead of a response type of code. After this, the flow continues as it did, but this time the access token is returned in the URL params instead of the authorization code. This flow is not as secure as the authorization code flow, but it is still possible to do if it fits your use case. In summary, the main benefits of OAuth 2 are secure authentication and authorization. It allows you to avoid security risks associated with simple login forms and squashes the issues of having to share passwords to access third-party resources. It eliminates the need to store and work with sensitive information such as passwords. It makes it very easy to work with third-party resources, meaning your apps have more possibilities available to them. User-controlled consent means that users are still in control of their data and know exactly what the app will access. And overall, OAuth 2 greatly improves user experience, as no one likes to make a ton of different accounts for different websites. It allows for users to sign in to multiple applications using a single set of credentials. Thanks for watching, and if you have any questions, please leave them in the comments.